Hello and welcome to another video about GUNT equipment for engineering education. In today's video, we will show you one of the classics within our product program, the mighty WP300 material testing unit 20 kN. In many countries, this type of equipment is also known as UTM or Universal Testing Machine. Today, we will show you a basic tensile test, including how to use the GUNT data acquisition system. The WP300, with its optional data acquisition system and the sturdy moving trolley, is perfect for your material testing teaching. Particularly together with the data acquisition, it's also the perfect vehicle for remote learning, as we will show you. Let me point out some of the unique features of the WP300. Here we have the large force indicator. Due to its large size, it is perfectly suited for the traditional teaching environment. It's actually a pressure gauge which indicates the hydraulic pressure in the actuating system, and it's calibrated in kilonewton. It also comes with a trailing pointer, which when reset at the beginning of the experiment automatically indicates the maximum test force at the point of the specimen failure. The elongation of the specimen is measured by an adjustable indicator up here, which indicates the relative displacement between the top crossbar and the crosshead of the unit. When using the GUNT data acquisition system, the test force is calculated by the system software via the measured system pressure from a pressure transmitter down here. The elongation of the probe is measured by an electronic displacement sensor. Let's start the experiment. We have to install a specimen into the testing machine. Here we are installing a round steel specimen with 6 mm diameter and 30 mm length. This is pretty much self-explanatory as shown in this clip. Alternatively, you can refer to the instruction manual of the WP300. Now we can move the top crossbar up and increase the test force by slowly turning the handle of the unit clockwise until the needle of the force gauge is just starting to move like this. We are now ready to record our test data. After the data acquisition system is connected to our PC with a USB cable and pressure and displacement sensors are connected as well, we start the data acquisition software. On the first screen, we select the type of test we want to carry out, in this case, the tensile test. Then there are a couple of customization steps we can take. For instance, we can change the color of the graph area. We can also select our preferred language. Next, we must specify the sample we are going to test. In the settings window under the view menu, we can either select a flat specimen and define thickness, width and length, or a round specimen with diameter and length. Under the File drop-down menu, we start a new measurement series, which we then name as we wish. After that, we can change the appearance of the graph, that is, its color, line type and width, according to our preference. As a last step in the experiment setup, we need to tear the system to reset all measurement values to 0. And now we are ready to record a proper load extension diagram. By the way, during the experiment and also after, you can change the view from a load extension diagram to a stress-strain diagram. For the recording to start, we press the record button here and slowly increase the test force by turning the handle of the unit. Please note that this clip is sped up for demonstration. Now you can see that we are traveling along the Hooke's line quite nicely until we reach the proportional limit at the end of the elastic area. From now on, the specimen will be permanently deformed. One of the neat features of the GUNT data acquisition software is that when the test force increases and approaches the upper limit of the screen, we can right-click anywhere in the graph area and select auto-scaling for the vertical force axis. It is recommended to turn the handle slowly and evenly for the best results. As you can see, as the test force continues to increase, the vertical axis of our diagram is automatically scaled up accordingly. By the way, if you pretty much know beforehand where you are going to end up with your maximum strength and elongation, you can set the maximum values for both axes by double-clicking on the respective numbers. Just about now we have reached the maximum tensile strength and the necking of the specimen starts. As our graph is reaching the right limit of the screen, we right-click in the graph area again and select auto scaling, this time for the x-axis. Here we can see how the necking rapidly progresses whilst the specimen is elongated further at decreasing test force until, bang, success, or failure rather, of the specimen, that is, which was the objective of our tensile test experiment after all. We hope you enjoyed this short video about one of the many experiments you can conduct with one of our classics, the mighty WP300 material testing unit 20 kN. For more information, please visit www.gund.de.